Lastly, we're going to look at multiplying radicals. In our last step, we practiced simplifying radicals. Now we're going to actually perform the multiplication operation on these radicals. And then, again, simplify. So the rule is you're going to multiply the numbers outside the radicals, which in our first example would be a 1, it's invisible, and a 1. When we multiply those, we just get 1. Then we're going to multiply the numbers inside the radical. 3 times 15 makes 45. And now we're back to step 3, where we had to break this down into prime factors. So this could be 9 times 5, which is 3 times 3 times 5. These are my prime factors. So radical 45 is the same as radical 3 times 3 times 5. I have a pair of 3's that can come out front. So my answer is 3 radical 5. On the next one, when I multiply them, again, 1 radical 12 times 1 radical 12 is 1 radical 144, which is just 12 times 12. I can pull a pair of 12's out and put it out front as 112, and there's nothing left in the radical, so 12 is my answer. In fact, anytime you have a radical multiplied by itself, the radicals cancel and we're left with just the number that's under the radical. Let's try this next one. 9 times 8 makes 72. Radical 5 times 10 makes 50. But 50 can be rewritten in its prime factorization as 5 times 5 times 2. And I can bring these 5's outside and write them once, so I have 5 times 72. There's a radical 2 left behind. 5 times 72 is 360. Radical 2, which is my final answer. 3 radical 2, the quantity squared, literally means 3 radical 2 times 3 radical 2. I multiply my 3's first and get 9. Then I multiply my 2's inside to get radical 4. Radical 4 is simply 2, so I have 9 times 2, which ends up giving me 18. Final answer. The last two examples involve the distributive property. We need to multiply first this radical outside times the first radical in the binomial, and then do it to the second term. So when I multiply radical 6 times radical 3, I get radical 18, plus radical 6 times 2 makes 12. And now I need to rewrite them with prime factors. 18 is 2 times 9, which is 3 times 3. Again, if it's easier to make factor trees, go ahead and make a factor tree off to the side. 12 is 2 times 6, which is 2 times 3. In the first radical, I can bring a pair of 3's out front, and I'm left with 3 radical 2. In the second radical, I have a pair of 2's that can come out, and a 3 is left behind under the radical. So that is my final answer. Last example. 2 times 3 makes 6. 5 times 6 makes 30. Again, we're taking the outside numbers and the inside numbers and keeping them separated. We're going to do the same. 2 times negative 4 makes negative 8. 5 times 8 makes radical 40. Now, when I rewrite this with its prime factors, 30 is 3 times 2 times 5. Nothing can come out in pairs, so I simply keep it 6 radical 30. On the next one, 40 could be rewritten as 2 times 20, which is 2 times 10, which is 2 times 5. I do have a pair of 2's that can come out and multiply to that negative 8 that's already there. So that gives me negative 16 radical 10. And that is my final answer.